Hello guys! Welcome sa ating z-knowledgeTV. Okay, so in this video, pag-aaralan natin ang another form ng indeterminate. Ito ang infinite minus infinite. Ang halimbawa ng equation ng limit na nakapagbibigay ng ganitong indeterminate ay itong equation na ito. Na kung saan, once na dinirect natin sinubstitute ang value ng x natin, okay, itong value ng x natin, dito sa mga x's natin, ang makukuha nating sagot ay infinite minus infinite. So, dahil dito, gagamitin natin ng L'Hopital's rule to determine the true answer sa ating limits. Okay? So, let's start. So, lahat ng ito ay pag-aaralan natin dito sa ating tutorial. Pero, before tayo mag-start, don't forget to like this video and click the subscribe button para ma-notify kayo sa mga next videos. So, let's get started. So, ito yung mga different types ng indeterminate forms. So, una natin na pag-aralan is itong 0 over 0. Next, itong infinite over infinite. At itong 0 times infinite. So, ngayon, sa ating video, ang pag-aaralan natin is itong infinite minus infinite. And then sa mga future videos pa natin, ating i-discuss itong 0 raised to 0, infinite raised to 0, at 1 raised to infinite. Okay? So, ngayon, pag-aaralan natin is itong infinite minus infinite. Okay? Okay. So, dito sa type ng infinite minus infinite, so para mas maintindihan natin kung kailan ba ito nangyayari, okay? So, let's take a look dito sa ating example. So, sabi dito, limits ng 1 over x minus 1 over sine x as x approaches to 0. Okay. So, dito, once direct natin sinubstitute itong value ng x natin, which is itong 0, dito sa mga x's pa natin, okay? So, ganito mangyayari. So, 1 over 0 minus 1 over sine 0. Na kung saan, ang 1 over 0 ay infinite. Okay? Then, itong sine 0, ang equivalent nito is 0. So, therefore, 1 over 0 din siya, so infinite din siya. So, lumalabas ng ating sagot dito, once na-direct natin sa substitute yung value ng x natin, so, infinite minus infinite siya. So, therefore, so, para makakuha natin yung true answer natin, so, gagamit tayo ng L'Hopital's rule. Okay? So, sulat natin ating given. So, yung limit ng ating given, wherein x approaches to 0, so, ito is pwede natin siyang i-simplify. So, gagawin natin is cross-multiply. So, 1 times sine x is sine x. Then, minus 1 times x is x over product ng denominator natin. So, x sine x. Okay? So, from here, so, ito yung gagamitin natin upang magamit natin ang L'Hopital's rule. So, sa paggamit ng L'Hopital's, i-derivative natin ang numerator at denominator. So, derivative ng sin x minus x. So, unahin natin i-derivative ang sin x. So, ang derivative ng sin x ay cosine x. Then, minus, derivative ng x is 1 over. So, ito is product rule. Okay, so unahin natin ang derivative ng sin x. So, still pa rin si x muna. Okay, then derivative ng sine is cosine. Okay, then plus. So, Ang i-derivative naman natin is itong x. So, as is muna si sin x. So, sin x, and then derivative ng x is 1. Okay? And then, simplify pa natin. So, magiging cosine x minus 1 over x cosine x plus sin x. Okay? So, dito sa ating first derivative, once na sinubstitute natin itong value ng x natin, which is 0 dito, so dapat makakuha tayo ng true value. Pero kung hindi, kung undefined pa rin, or indeterminate pa rin, so magsa-second derivative tayo. Okay, so substitute natin ng 0 dito sa x. So cosine 0 is 1 minus 1, 0. Okay, so cosine 0 is 1. Next, sa denominator, cosine 0 is 1. Okay, and then ang sine 0 is 0. Okay, and then ang x natin is 0. So therefore, 0 times 1 is 0 plus 0. So therefore, 0 to. So therefore, sa ating first derivative, nakuha pa rin tayo ng indeterminate na 0 over 0. So pupunta tayo ngayon sa second derivative o second L'Hopital's. So i-derivative lang natin yung itong first derivative natin. Okay? So copy natin. Cosine x minus 1 over x cosine x plus sin x. Okay? So, kuha natin ang derivative ng numerator at denominator. So, ang derivative ng cosine x is negative sin x. At ang derivative ng 1 is 0. So, minus 0 over, so, another product rule. So, ito muna ang unahin natin. So, x, then derivative ng cosine is negative sine. Plus, so, copy natin si cosine x. Then, derivative ng x is 1. Okay? Then, plus, ito naman. So, derivative ng sine x is cosine x. Okay? Then, simplify natin. So, matitira sa taas, sa numerator natin is negative sine x over, so, dito naman, cosine x plus cosine x is 2 cosine x. Okay? Minus x sin x. 2 cosine x minus x sin x. Okay? Then, saka natin substitute yung 0. So, dito, ang sin 0, okay, sulat mo natin, 2 cosine 0 minus 0 sin 0. Okay, so ang sin 0 is 0. So, 0 to. Okay, then ang cosine 0 is 1. Okay, so 1 to. And then ito, pag pinag-multiply natin is 0. So therefore, may matitira tayong 0 sa taas kasi negative times 0 is still 0 over 2 times 1 is 2 minus 0 is 2. And any number na kapag dinivide mo sa 0 is 0. Okay? So therefore, ang limit natin ng 1 over x minus 1 over sin x as x approaches to 0 ay 0. Okay? So next. So dito sa another example natin, so limit ng 1 over e raised to x minus 1 minus 1 over x as x approaches to 0. So kapag direct natin sinubstitute itong 0 sa mga x's natin, so ganito yung kalalabasan. So, 1 minus e raised to 0 minus 1 minus 1 over 0. So, kung saan ang e raised to 0 is 1. Then 1 minus 1 is 0. So, magiging 1 over 0 minus 1 over 0. And then ang 1 over 0 ay infinite minus another 1 over 0 na infinite. So, pupunta tayo ngayon sa indeterminate form na infinite minus infinite. Again, so dahil dito, gagamit tayo ng L'Hopital's rule. So, pero bago yun, so isimplify muna natin itong equation natin. So, cross multiply lang tayo. So, lalabas x minus e raised to x minus 1. So, iyan muna natin siya. I-group muna. Okay? Over. So, product ng denominator natin. So, x e raised to x minus 1. So, simplify natin. So, x minus e raised to x plus 1 over x e raised to x minus x. Okay? So, dito, since may numerator at denominator tayo, pwede natin gamitan ng L'Hopital's. At i-derivative natin ng numerator at denominator. So, para sa first derivative, so, derivative ng numerator is, so, derivative ng x, 1. Derivative ng e raised to x, still e raised to x. And then, derivative ng 1 is 0. Over, so, ito, product rule. So, copy mo yan sa x. Then, derivative ng ex is still ex. Okay? Plus, copy naman natin si ex. Then, derivative ng x is 1. Okay? Next, ito naman. So, derivative ng negative x is minus 1. Okay? Then, simplify pa natin. So, dito, ang lalabas is 1 minus e raised to x over, dito naman, so lalabas, sila pa rin, e raised to x minus e raised to x minus 1. So, plus to. Okay. So, try natin substitute yung 0 natin dito sa ating mga x's. So, kapag indeterminate ang lumabas, so, pupunta tayo ngayon sa second derivative. Okay? So, 1 minus e raised to 0 over 0 e raised to 0 plus e raised to 0 minus 1. So, e raised to 0 natin is 1. So, ito is 0 kasi nakamultiply sa 0. Ito is 1. Okay, so 1 minus 1 is 0 over, so 0 plus 1 minus 1 is 0. So, again, nakakuha tayo ng indeterminate form na 0 over 0. So, pupunta tayo ngayon sa second L'Hopital's. So, pagkuha ng second derivative. So, kukuha na natin is ito. Okay? So, sulat natin siya. 1 minus e raised to x over x e raised to x plus e raised to x minus 1. Okay, so derivative natin itong taas. So, derivative ng 1, 0, minus derivative ng ex is still e raised to x. Over, so ito naman, derivative na to is x, e raised to x pa rin, plus e raised to x times 1. Kasi derivative ng x is 1. Next, ito naman. So, derivative ng e raised to x ay siya pa rin. And then, derivative ng minus 1 is 0. So, simplify natin. So, negative e raised to x over, so, x, e raised to x. So, e raised to x plus e raised to x is plus 2 e raised to x. Okay? So, saka natin i-substitute ang ating 0. Okay? So, magiging e raised to 0 over 0 times e raised to 0 plus 2 e raised to 0. Okay? So, e raised to 0 is 1. So, therefore, magiging negative 1 yung taas natin. Over, ito is 0 to. Then, ito is 1. So, matitira sa baba natin is 0 plus 2 ay 2. So, therefore, nakakuha tayo ng sagot na negative 1 half. So, therefore, ang limit ng 1 over e raised to x minus 1 minus 1 over x as x approaches to 0 ay negative 1 half. Okay, next. So, paano naman sa ganitong example? So, limit ng x squared over x minus 1 minus x squared over x plus 1. So, kapag direct natin substitute yung infinite natin dito sa mga x's natin, so, ganito yung lalabas. So, infinite squared over infinite minus 1 minus infinite squared over infinite plus 1. Okay? So, infinite minus 1, still infinite yan. Infinite squared is still infinite. So, infinite over infinite. So, infinite over infinite minus halos same lang. Okay? So, since na indeterminate ang nakuha natin, so, gagamit tayo ngayon ng L'Hopital's para makuha natin ang true answer natin. Okay? So, but before that, so, simplify natin itong equation natin. So, cross-multiply lang tayo. So, ito is x squared multiplied by x plus 1 minus x squared multiplied by x minus 1 over, so, product ng denominator natin ay x squared minus 1. So, pagsamahin natin, so, mangyayari is x cubed plus x squared minus x cubed plus x squared over x squared minus 1. So, cancel na itong x cubed natin. So, matitira is 2x squared over x squared minus 1. Okay? So, ito yung gagamitin natin para kay L'Hopital's. So, di-derivative natin itong equation natin ngayon. So, using first derivative, so derivative na to is 4x over derivative na to is 2x minus 0. Okay? Then, itong 4x over 2x, so cancel na lang to. Itong x, so matitira is 4 divided by 2 is 2. Okay? So, sa unang derivative pa lang, nakakuha na tayo ng true value. Okay? So, therefore, ang limit ng x squared over x minus 1 minus x squared over x plus 1 ay 2. Okay? So, next. So, paano naman kapag ganito yung ating equation? So, dito is limit ng secant x minus tan x as x approaches to negative side ng o left side ng pi over 2. So, kapag substitute natin itong pi over 2 rito, so, dapat makuha tayo ng true value. Pero kung indeterminate makuha natin, so, gagamit tayo ng L'Hopital's. Okay, so, substitute natin secant ng pi over 2 minus tan ng pi over 2. Na kung saan, ang secant pi over 2 is pwede rin gawing cosine pi over 2. Minus, itong tan is sine pi over 2 over cosine pi over 2. Okay? So, dito, ang cosine pi over 2 ay 0. Okay? So, ganoon din dito sa kabila. And then, itong sine pi over 2 is 1. So, therefore, 1 over 0 is infinite minus infinite 10. Okay? So, gagamit ngayon tayo ng L'Hopital's rule. So, copy natin yung equation. Secant x minus tan x So, ito yung ang equivalent nito ay 1 over cosine x minus sine x over cosine x. Okay? So, since sa parehas yung denominator, pagsamahin lang natin ang numerator. Magiging 1 minus sine x over cosine x. So, since may numerator at denominator tayo, pwede natin silang i-derivative. So, using first derivative, derivative ng 1 is 0. Derivative ng sine is cosine. Over, derivative ng cosine is negative sine x. Okay? So, ngayon, lalabas na dito is negative cosine x over negative sine x. So, negative divided by negative. So, cancel lang yon. Okay, so once na-substitute natin itong pi over 2, so cosine ng pi over 2 over sine ng pi over 2. Cosine ng pi over 2 is 0. Okay, and then sine ng pi over 2 is 1. So therefore, 0 over 1 ay 0. So therefore, ang limit natin ng secant x minus tan x as x approaches to pi over 2 or left side ng pi over 2, so 0 ang sagot natin. Okay? So next. So paano naman kapag ito yung ating equation? Limit ng x over x squared plus 2x minus 3 minus 4 over x plus 3 as x approaches to negative 3. So could you able to answer this? So if yes, please comment your answer. Okay? So dito na nagtatapos ang discussion natin about indeterminate form, infinite minus infinite. At sa ating next video, ang pag-aaralan naman natin ay ang 0 raised to 0. Kung saan, once na sinubstitute natin directly ang value ng x natin sa ating equation, okay? So, makuha natin ay 0 raised to 0. So, dahil dito, gagamit tayo ng L'Hopital's rule to determine the true answer sa ating limits. Okay, so stay tuned lang sa ating channel. So, maraming salamat.